Hey, good morning. So today we're just gonna, I guess, keep using our skill set. I think there's a couple questions still around factoring versus completing the square. So today we're gonna take a look at both. There are advantages and disadvantages to each. So I want you to think about 3 steps. Remember, we're using factoring and completing the square to find x-intercepts. So when we're thinking about using these tools, the first thing would be, let's just check the graph and let's verify there are x-intercepts. If there aren't, then there's no point in doing those because we won't solve for anything. But if there are, then we can say, okay, let's try factoring. If it doesn't work, then let's jump to our complete the square. So first off, if I look at example 1 here, I want us to factor this. Well, first, let's verify that it is factorable. So if I go to wrong screen, so if I go here, sure enough, this parabola has x-intercepts. If I zoom out, I can see clearly that it's crossing the x-axis at 2 different points. All right, cool. So now if I look, let's actually factor this. So remember, we're looking for x-intercepts, so our y value is going to be 0. And factoring, remember, just means, can I jump straight to the box? So I have my x squared. I've got my negative 24. And now I'm thinking factors of negative 24 that are going to combine to get me a positive 2x. So when I'm thinking about this, remember I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So when I think about all of these, I think the only ones that have a possibility of getting me a 2 are the 6 and 4. But because it's a positive 2, I'm betting I'm going to need a positive 6 and a negative 4. All right, because negative 4 times x is a negative 4x. X times positive 6 is positive 6x. And sure enough, if I were to write this out, these two things would combine to be a positive 2x. All right. So now, remember, I'm just looking for the x values that are going to make this equal 0. Well, conveniently, this one I can see that if x is a positive 4, or if x is a negative 6, both those are going to work. And so, here are my x-intercepts. All right, and that's that. And I can quickly go back to my graph and I can verify, sure enough, those are my x-intercepts. But I do want to demonstrate another idea. Let's take the same equation. We already factored, we already solved. Not necessary to complete the square to solve for x-intercepts again. We already know them. I just want to prove a point here. Turns out that completing the square would still get us the same thing. It's just unnecessary in this fact. But let me just prove it. All right, the first thing I'd need to realize is because I have a plus 2x here, to make this a perfect square, I would end up needing a 1 on the end. And feel free to verify that for yourself. And so I'm going to have to add 25 to both sides. All right. Now I'm betting if I make the box that this thing factors into a perfect square. So in this case, it's going to end up being x plus 1 and x plus 1. Because I get a positive 1x, which will combine to be a 2x. So it's going to be x plus 1 times x plus 1 equals 25. Or 25 equals x plus 1 squared. All right, so remember, when I'm completing the square, I want to get rid of that exponent. So that's going to mean that I've got to square root both sides. Normally, we just leave it as a square root, but if you think about it, square root of 25 actually has an answer. It's going to be 5. But remember, there's the other possibility that the square root of 25 is also -5. So we got 2 possible answers. And now, if I subtract 1 from both sides to finish solving, I'm going to get x equals 4. Subtract 1 from both sides, and I'm going to get x equals -6. So notice how I get the exact same solutions by completing the square. It's just this took me a lot longer than if I just realized that it's factorable. So technically, I was done already. This is just demonstrating the point that if you make a mistake and you don't realize it's factorable and you jump to completing the square, you'll get the same answers. It's just going to take you longer. All right. Now let's jump to example 2. If I take a look at example 2, the graph, sure enough, I've got x-intercepts. All right, so step 1 approved. Now I'm going to jump to factoring. So the question is, are there factors that'll make this possible? And if I look at this, I know I'm going to have x and x, but really the only possibilities I have for down here are +1, +1, or -1, -1. And there's no way that that's going to get me -6x in the middle. So no matter what I try, this one's not factorable. But based on the graph, we clearly saw that it has x-intercepts. And so what I've got to do now is I've got to say, well, it's not factorable. My easier strategy isn't available. Now I got to jump to completing the square. And so I got to look at this and I got to say, what number's got to be on the end to make it a perfect square? So if you take a look at our last class's work, you're going to see that we already did one like this, where if I have a -6x, half of that's going to be -3. So I'm going to end up needing a +9 on the end. So actually, that's bad. Here, to make that a +9, I'm going to have to add 8 to both sides. Sorry about that. Cool, leaving me with this. Now, you can make the box, or some of you may have jumped right to knowing what the factored form is already. But because it's a -6x in the middle, I'm going to end up needing an x -3 and an x -3. So now I know that 8 equals x -3 times x -3. Some of you jump straight to this step, which is okay. I'm just making sure we understand where all the pieces are coming from. And now I'm ready to say, what is the square root of both sides? So these are going to eliminate each other, leaving me with the square root of 8 equals x -3, and negative square root of 8 equals x -3. All right, and so just add 3 to both sides. I'm betting if you had checked square root of 8, you got a decimal. It's not a nice whole number. So we can just leave it as square root of 8 this time. That's going to happen if something's not factorable originally. All right. Cool. So there are my 2 x-intercepts at square root of 8 plus 3 or negative square root of 8 plus 3. Remember, I'm technically done. I can leave it like that. There's nothing wrong with that. But let's go to the graph now. So these are our 2 x-intercepts, but notice how they're as decimals. So if I'm using Desmos, all I'm going to do is I'm just going to say, okay, let's type in our square root, SQRT, of 8, and then plus 3. And notice how when Desmos converts that to a decimal, it matches the decimal that's the x-intercept on the graph. And I can do the same thing here. Let's say, what about if it's the negative square root of 8 plus 3? Here's this decimal. Let's compare it to the graph, and sure enough, they're the same. Just remember that 2's there because they rounded. All right, so this is just confirmation that my x-intercepts match my completing the square. And that's all there is to it. So for today's assignment, the first thing you're going to do is just kind of test both strategies on multiple equations, and then I'm going to let you choose which strategy is best. So if you have questions, as always, reach out. Otherwise, good luck.